Okay, so welcome back. It's the second episode of the game Anomaly Hunter or Anomaly Discoverer. I guess I would change it later on, or maybe add some combat system for fighting. So projects Anomaly Discoverer. Um, so no AI. Oh, we got 4 days left. So this step is done. So what were the next steps? Oh yeah, we need to create the ocean system, but I think we will be working with that a bit later. Okay, lake system. Then it should be grass. Like now, let's just earth, and it will generate grass. Grass. Yeah, we can do rock. So sorry, water. No, it's not water. Yes, we can generate sand, but sand itself is a sand. Rock, snow. Okay, ice. What is mud though? What is the difference between rock and stone? Anyway, we got animals. Animal. We can generate some fruits, and fruits. And I do believe this is it. So basically, there will be earth, and it will be filled with either grass, rock, animal, or fruit. Okay, so first of all, let's get those things. And we need grass, rock, animal, and fruit. So grass is an easy part. Just draw some grass. Um, mm, mm. Just some custom size. I guess 100 pixel by 100 pixel is enough. 100 pixel by 100. And we work with the Pinterest. I guess we can get some things from there for free. Okay, so we need. I actually like this. Animal speed PNG. So what kind of animals we got? Animals animated. Well, it's not ChatGPT. So we got a cute some animals. Oh, yeah, let's do chicken. I'm liking this one. Yeah, no, not this one. Yeah, this one is fine. Seems fine. So we just copy image, put it here. So if I download it and do that transparent background, okay, then we need some grass system. It will be like grass. I guess we can find from here. I'm liking. Oh, I like this one. What actually? I'm thinking to do it like here and like position to front. Okay, not the greatest thing. I developed this works fine as well. So grass, animal, yeah, fruit. Oh, I like this one. What type of fruit to be? Banana. Oh. They will be collectible. They will be and then the rock. Okay, you need the rock. The array of rock. Ah. Share, download them all, PNG. Yeah, download them all. And we use something called like bugger remover. We get it for free. So downloads, untitled design. Okay, let's close the Telegram. Okay, I don't know what was that. Okay, let's one by one. We're going to download this. Oops, sorry. Here. Magic. There is also one way of doing it through Photoshop.
The image to convert it. So by default, the texture type is default. So I'll just need to select Sprite 2D and UI to change it into Sprite. and then we need to select the sprite I want to convert to sprite, so I'll just drag it into the images folder I just created, and I select the image to convert it. So by default, the texture type is default, so I'll just need to select sprite 2D and UI to change it into sprite, and then we need to select the sprite mode. I'll just select a single for now, and now we have we need to apply it, press apply, and now we have sprite ready to be used in anywhere where sprites are needed. For example, if I have a UI element, so right click UI image, and I'll select the image, and the image will ask for source image as a sprite. It's accept sprite, so I'll just click here and enter the name of the sprite we have. So I'll just
So I do believe it's just for the images. It's a game object, not UI. Oh, I love this.
Hi, this is a very quick and dirty way to add images to your objects inside Unity. So now what I've done here is I've taken images from the internet. Credits will be put in the description. But basically you have these images, and now what we can do is
I don't need to.
put them into our Unity project like so. And if we have any empty objects that just have the default texture, we can just drag the images on top of them. See that it creates the materials automatically, and you can see the immediate reuse here.
Yeah, that was a dirty. That was a dirty. Unity 2D.
Hello everybody, Chris here, and in this video, and if you're that efficient, then in we can decide preferred. So I'm going to decide everything A after pre-order, and on might add a sheet, but to these none for the compression, the compress, as well as that, because this is the point, and none for the compression. So go ahead and hit apply. And so if we pull this section here where we can, if there's any not deeply visible for us, we want the frames to be equal to grid by cell count. If you know the pixel size of each of your frames, you can do by cell size instead. But if you don't know the cell size, then going by cell count might be easier, because all you need to do is count the rows and the columns. So we can see there is 1, 2, 3. So we just put 8 for the columns, 3 for the rows, hit slice, and now all of our frames are perfectly sliced with each other. They have the same size and shape. So that's going to enter now. Let's go ahead. This has been saved here, and there we have tiny compared little frame. Drop it on drop white, because this
Sprite renderer. That's what we need. So sprite renderer. I guess I don't need this. Okay, let's create from the back, from the start. And sprite renderer. Here in the sprite we just add animal. Not cool. Not cool. Okay, so yeah, that's pretty cool. So game object size is 111 0 0 and 0. Layer. Let's add new layer. Call it collectibles. So the logic will be like this. Some blocks, I meant the earth block, will contain these collectibles. So sorting layer, we here add collectibles, and let's so blocks are shown first, then collectibles, then the player itself. Well. So rename that as a fruit. Control S, Control V. Rename that as grass, and here we need to rename that as a rock. So prefabs, we don't need any more prefab anymore. We don't need 3 prefab anymore. So we got to choose this 3 prefabs mod. Blocks, it's getting complicated though. Just a field or field. Yeah, or block of earth. Yeah, block of earth is better way. Here's the grass. So blocks contain earth and some holes. Actually I'm not liking how it's called holes. Just call it obstacle or unwalkable area. Obstacle, mountain, fruit. So here we need to add a grass thing. Yeah, apply changes. For the rock we need to add a rock thing and delete them all. Yeah, and for them all we need a layer to be collectibles, and layer actually we don't need this for now, at least. So yeah, the game is working. And we need to change this mountain settings. Actually, I would like to be able to move only by the cells. Like if I press a button, it will move here, and I cannot be standing like there. I don't know if it's possible. I mean, there is one way of doing it by adding. Oh, let's first create some. Okay, world creator. If it's not full, it's obstacle. Then if it's mountain, so what it does? Yeah, it does. It makes sure that the standing area is grass. It is earth. I meant you cannot spawn in the mountain or kind of thing. Also I want to add if, you know, you can add if I equal to minus W or I equal to W or sorry or J is equal to minus H or J is equal to H. So random nap to be set, random nap to be set to. Okay, and here I'd like to mention them. I'm liking this, though it can be considered as an AI. So let's write myself. One is mountain, two is obstacle. Okay, so this in theory should create the world where I cannot live like this. Yeah, good. Which is nice. Nice. So as you can see, I cannot move like over there. Oops. Oh, yeah, it's a dead end. I'm liking the world generation. It could be like a labyrinth or something. So okay, now for the earth component. Actually, let's create a new prefab, call it a new empty object, call it like how was it called? Okay, I guess I need some help of some other previous code. Yeah, let's open Visual Studio Code. And yeah, I don't need this. Okay, so we need a new file, open folder. The desktop users. Yeah, this project, assets, codes, scripts. Okay, here I got all of my scripts. I don't need them at all. So game over script, level, main menu. So there should be one script, call it this project titles, plots. Yeah, there. Here is enemy transform, move speed. Oh no, it was in the path manager. So level manager and then path manager. That is it. So that's the code I need. So let's see how can we implement this together. It's like waypoint. So let's call that a waypoint. Waypoint. And waypoint, the position will be 2 to the 0. And we need to add this beautiful item. Should it be trigger or something like make world public transform waypoints. I guess we need a new script for this, and call it path manager maybe now, like pathing. Player controller, player movement. But player controller. Player movement now. Player path path path. HKKS now path manager. Path player path player paths player paths player path. No, we can add it to the player controller actually. Ops. So yeah, public transform waypoints. Yeah, that's called waypoints. So it's gonna be the empty one for now. So private void away. So we need to add game object game object or array of game objects, because game objects is equal to game object find game objects, this tag waypoints. So then we got order by. No, actually we don't need order by. We need a select object. So it basically translates the it basically gets transform. So and then to array. I'm quite not getting the logic of this. Yeah, so objects and then objects transform. Yeah, oops. So waypoints are equal to objects. Yeah. Select. So waypoints we got their transform and then translated it to the array. Enemy. Here we don't use the fixed update thing. Do I use it? I don't know though. I could ask the ChatGPT, but I don't know usage of AI though. Um, so while moving, yeah, let's create something called is moving. This is not working at all. So we don't need this, and we don't need this. Game objects. So let's go with logic. There will be game objects. You know what? So in the start method, let's debug log waypoint length is to be equal plus waypoint length. So we got waypoints. Now to the Unity. New tag called waypoints. Yeah, waypoints. Save. Our tags should be like this. With tag waypoints. So tags are the same. Now we need a cresting to the earth. Open this up. Perhaps earth at the waypoint right here, right in the middle of it. So Ctrl S, Earth, ouch, waypoints, yeah, overrides. Hmm. Yeah, I guess we just need to order thing. Order by descending, order by name. Yeah, order by object name, order by object, object. Stop. If you delete this, and let's do something crazy. Not after the start, but after each frame. Yeah, tons of zeros. So let's stop. Let's stop for a moment. So it cannot detect. Oh, point or yeah, if it's grass, then where is our world generator? Yeah, world creator. Okay. So here, yeah, it's gonna get messy, but at one point I do believe we can fix it. Serialize field private game object game object and then waypoints. I guess it's the same naming, but waypoints. Yeah, let's go with VC world creator. No, now let's be the same because they got the same, almost the same values. Follow player, solid player controller. Wait, actually, do we need this? Yeah, that's under the questions, but we need to be able to check it. So we need game private game object. Now it's like one game object. Waypoint. Yeah, so here is a difference in the player control and the player controller. There is waypoints, and here it's just a waypoint, and with that if random number is equal 0, instantiate, and then here if random number is equal 0. What is that? No, it's not. I don't need this. I know what he's trying to do, but right at this moment we don't need it at all. Actually, that's a quite nice idea. But I would like to create another thing. Instantiate. Yeah, we got a waypoint, and there is the same other values. Apply it here. Transform rotation, transform vector ig. Yeah, I need probably to assign the value. So world creator waypoint. Layer. No, actually we don't need them at all. No, we need them, but it's like the after world has been generated. So private void make world. Yeah, let's them here awake. Then player controller. I do believe in this way it must work. And then debug log. So the order matters a lot. Yeah. That is it. So now we need to check a distance thing. So I got a quite nice idea. Basically, oh yeah, and so I believe I need my defenses. Here I wrote something called like Okay, so right cast. Okay, then another unit tutorial how to check the distance between objects in Unity.
If we know the position of two objects, we can determine the distance between them. I just need a minute to prepare all we need for this exercise. First, I'm going to create two spheres to measure the distance between them, a canvas text to display the distance, a new script, and an empty game object to assign it. Inside the script, we define the text variable, in this case TextMesh Pro, video in the corner for a complete guide on this. We also define we another result will be target within this function, and then write this variable to the canvas text, converting its example value using this function.
Okay, so we need a distance though, and we need the distance and then this distance and position, like their direction and direction. How to check the direction? You know what? We can do something crazy. So in the player, yeah, in the world creator, we need to create the private grid grass, private grid world. This grid world is using already. Private integer. So walkable area. Walkable area grid. Uh, E and G is equal to 1. I'm wondering if that can be I believe it won't give us a mistake, or will it be? Yeah, it is gonna give us a big mistake. E plus G. Mm. Okay, let's do it the other way around. 0 0. There is no dot for the plus thing, and there is no like. Yeah, it's not needed at all. Grid world. Okay, if I is equal 0, and then j is equal 0, or the age plus I. Grid grass. Grid. Sorry, but why don't you do that? Then need I and G. That's it. Hmm. The player position. Yeah, position player. Let's like in 20 to 10. A player controller. Public static player controller. Player controller instance is equal this. Position the player. So need a player controller. Точка main. Точка position player. Avoid the weak fixed updates. Position player to be public void. Transform position new vector. Yeah, integer width and integer height. New vector weight, height, and 0. New vector 3. bounding vector 3. Oh, I got where I made a mistake. So walkable array grid. Yeah, no, this is it. A main position player. Player controller, main position player. So we need a world creator which can create world on by 40 to 20. No, 60 by 30. Main to create world, and then player controller, main player position 15. Yeah, 15 is enough. So it will put 15 like there. Main is equal this, and then we here we need to create the public static world creator main. Sorry, make world. Am I what making it? No, it must start with start, because in the awake method they all get their values, and when the press starts, oopsie. So I do believe the right side is also out of space. Yeah, luckily it's quite easy to fix. Well, in the world creator we just need w minus 1 and h minus 1. Need to get the world 60 by 30. Oh. Okay, so okay, it's like 6, 9, 12, 15, 18, 21, 24, 27, 30. Yeah, let's add collectibles. Serialized field. Oopsie. Private game objects. Collectibles. So if walkable, instantiate, we need to instantiate waypoint and then instantiate collectibles random ops. Yeah, it's giving me everything, you know, and giving me correctly. Collectibles of random in the range of from 0 to collectibles length, and then new vector 3, the same values I, j, and 0 f, then transform point rotation. I don't think we need this f. No, we can do that. No, not. No need. Let it be spawn where it must spawn. So now we need to add collectibles. So those are our 3 collectibles. Create folder collectibles. Okay, so then world creator. Very strange. Ah, here they are. Okay, just collect them. That's, you know what? So I'm actually kind of. Oh shit! Oh, there is something wrong going on there. So layer. Ah, wow. Collectibles. Okay, that's strange now. What's wrong? Ow! So players is on the top. Sorting group. Sorting group. Collectibles. Up. Going through rocks. They're quite funny. That's quite funny. Yeah, I'm happy. At least it's working now. So active percent. Okay, so if active percent 10, then I love my this function, you know. So in 40% of the cases, it will give something. There's a grass. Grass. Oops. Yeah, now I need to finish the hard part, which is make player move in a nice way. So, okay, for that we need. What do we actually need for that? We need a mess of things. We need a massive thing. No player control. Public public integer. No. Play public player player position. Let's do it in the float format. So we're gonna update. Yeah, so player position is equal new node. W2 float. Sorry, but can they be this or the same thing? No, it cannot be. So let's stick with integers. No. Ow. Yeah, that's it. That's it. Yeah, so we need to movement in Unity. Movement in Unity to the, so it should be 4 types, like 4 types.
If you've ever been confused about the many ways you can move your player in Unity, or you just wondered about the differences between them, we're going to clear that up right now. Ready? Let's go. So I've got these 4 little guys here, and if I move them, they're going to turn blue when they cross this trigger, so we know that's working, and they'll turn red when they collide at the end here. And some of them behave better than others. So let's jump right into the first one and take a look. Our first method is translating the player's transform. And I don't mean that transform.translate is the only way to do this. You could change the position directly like this. You could also make it equal a vector3.lerp. You could use a third-party tweening library that smoothly moves your transform from A to B. It doesn't matter. Under the hood, these are all doing the same thing. And that is, we're directly changing the transform.position of the game object. And because that does not require physics calculations, we can do it in update instead of fixed update. And we do need to make sure that we multiply our movement by time.delta time. And if you've ever been confused about why you need to do this, time.delta time is the time since the last frame. The reason we multiply it is to keep our speed the same regardless of the frame rate our game is playing at. If we have movement velocity of 1 unit on the x, and we multiply that by time.delta time times our number of frames per second, we'll get 1 unit per second of movement. It doesn't matter what our frame rate is. That's why we multiply by time.delta time. Now you can see I do have a collider and a rigid body attached, so collisions are technically working, but our transform changes are conflicting with the physics collisions, and that conflict is causing our player to sometimes jitter when he hits the walls, and sometimes he just goes right through them. So because of that, if we move our player this way, we do not want to rely on physics for collisions. Instead, we'll probably want to write our own collision detection. It could look something like this. Keep in mind, this is really rough and it only handles collisions from the right side, so in a top-down, we would need to do it for the left, up, and bottom as well, but you get the idea. With that in place, after removing our rigid body, you can see he stops really smoothly. It is a lot more work to create your own collision detection up front, but a lot of developers do like moving their character this way because it gives them really precise control over every aspect of movement, including collisions. And it's worth mentioning, if you have a kinematic rigid body attached, you can still detect triggers using on-trigger enter2d, but as you can see, he does not turn red, so on-collision enter2d does not get called. This method is similar to the last one, except we're directly setting the position of the rigid body instead of the transform. Therefore, collisions are automatically going to work so long as you stick this in fixed update, not update. We need to account for different frame rates here as well, so we multiply by time.fixed delta time since we're in fixed update. Although little tip here, you can still use time.delta time. Unity will just convert it to fixed delta time for you, so you really don't need to worry about using fixed delta time. Now also, whenever we move using rigid bodies, we need to set this to interpolate, or we're going to have jittery movement. To show you movement without interpolate, here's what it looks like running at 5% speed so you can get a good look at it. You can really see that he is moving at a fixed rate. And here's with interpolate at 5% speed. Interpolate basically fills in movement where there's a difference between the fixed time step and the amount of frames running, so it's always going to be smooth. Now, even though physics collisions automatically work with this, if we try to apply forces to this, they're going to conflict with each other. I have this little script that makes my guy dash if I press space, and you can see it works, except it never stops working. I'm moving him around, and if I just keep on pressing it, it's just going to keep building up force, and as soon as I stop moving, he's going to go flying. And that force will not stop until I hit a wall. So overall, this is actually a great way to move your character. You get all the precision from the last method with the bonus of getting collisions working right out of the gate, but you're going to want to stay away from applying forces to the rigid body because this movement does conflict with that. By the way, if you're enjoying the video, I just want to say thank you if you drop a like or a comment down below. Now, with this one, we're adding a force to our game object. We've got two modes we can choose from, force or impulse. Force you can think of like a car with a buildup of speed, whereas impulse is like a bullet, it's just instant speed. But with this method, multiplying our move speed by our movement isn't technically a speed, this is going to act as an acceleration instead. You'll notice with this method again, you have to do it inside of fixed update, but since it's a force, you do not need to multiply it by time tilde time. You'll notice that, again, we need interpolate, and yes, collisions do work right out of the gate, but there are several problems with this. Our movement, for a player, is horrible. It's really slow to speed up, and if I move in the opposite direction, then he has this long deceleration time before he goes in that direction. And also, unless I add drag to this rigid body, once he's moving in a certain direction, he will never stop until he hits something. Also, he can speed up infinitely, to the point where he's going so fast he'll clip right through this glider because he's moving further than that amount of distance each fixed update. Though I will say that was with discrete collision detection instead of continuous. Continuous handles high-speed collisions a lot better. But we could fix that with a little bit of extra code. We could add a max speed, and maybe only apply forces if we're moving in a certain direction, and if we're not moving, maybe we apply a force in the opposite direction. And all of a sudden, with the right combination of values, we have a really nice feeling move with some built-in tweakable acceleration and deceleration. And bonus, we can use forces with this as well. So we can be walking and use add force as well, which is great for knockback and dashes and things like that. There's a lot of built-in perks with this method, but it is more work up front, and not everyone likes working with the built-in physics for movement, so it really depends on what you're going for and how much precision you need. This is one of the simplest to get going right out of the gate. There's like barely any code here. Now, you'll notice that's it's up here. Why? Which is why. He hits the walls, and sometimes, but you get the idea. Like this. So, put measure moment. You could also make it equal a vector3.lerp. You could use a third-party equal a vector3.lerp.
So it's speed, so we don't need this at all. So our player will be in the one position. So transform, translate. No. If input point manager. Now input get key down. What key code D. If is included, so is included, and with that we are gonna give our player position. Boolean structure. So player controller and player position WH. is included. Yeah, is walkable. Is walkable. Walkable array grid. Walkable array grid. Is walkable. Is walkable. So is walkable. So we got to give x by any chance. So first comes the width. Yeah, so it's like xy. No, let's write here like here xy. Otherwise, I'm really confusing. So player controller is walkable. So we need to give the value of x and y is walkable. So here we need to have integer x and integer y. I believe integer x position and y position. Yeah. So we don't need this actually. W plus x position and then y position. Walkable area, walkable, not walkable. Teacher. So it's if walkable bossa значит player position is equal 0 and the player x plus position new player position and then player position which is old one and then we make it player position new one. I believe no errors will be detected. So we cannot move. Okay, so not walkable. Yeah, not. Yeah, it's like not giving us not walkable. So okay, not walkable. Again, not walkable. Okay, so That's quite strange though. Player position X, and then we got a player Control S, then Control V. Player position. Now, like let's call that as a position X and position Y. Easier to understand. Position X, position Y. So when it will be given like position X is equal to W, and then position Y is equal to height. Vocabulary grid. So handle movement. W. So we get up and down. Else if, and then else if. We don't need this. We got the position X, and then position Y. Position Y plus Y pos. Oh shit. That that's the issue now. We don't need this. I meant we need this else. This and that. Walkable array grid is to be this one. A player position. We don't need this. Simply don't need this. Sorry. Grid grass. I don't think we need this either, but we need this grid world thing. So, do we actually need this? Because if I do this and if I do this, all we need is a walkable array grid actually. So walkable array grid, that is it. So we are giving our players like 15 to 15. So if I is equal to 15 and this is 15, yeah, walkable. Okay, so again walkable. Hmm. It cannot be forever walkable though, according to my logic. Then we got I don't know what the hell this mistake is. Oh shit. Yeah, that's insane. I know it's gonna suck up somehow. Mm-hmm. Now, if I do this, it's not gonna give. So, and then position Y is the same, will be like this. I hope it's. Well, I know that it's gonna give an error now. You know what? Let's do some crazy shit. no, yeah, it's not walkable. So okay, walkable. Yeah, not walkable. Yeah, stop. It's walkable. Clap. You know we can handle movement if is walkable. If it's walkable. Whenever those keys are pressed, so when it sorry, now we need a private boolean. Private boolean is walkable. Is walkable array. True is walkable array is true. No, null point alt. Null point alt F. Null point alt F. Oh, position X. Shit. Errors after errors.
You're the hood. You
Done for. Move. So, if I got that correctly, then it's going to move from position X to the position Y, to the position Y, and I'm sorry, to the position Y plus 1. Oops. Lol. The package log position X and then position Y. String. Oh, nice. So would that work if like I make this mountain, if I make this mountain rigid body, not static but kinematic? Yeah, it works. I don't need a rigid body anymore. So it's for obstacle. Okay, the hard part is over. Is there a way to translate it a bit? Like, okay, let's do it. For I is equal 0, for I is equal 0, yeah, integer I is equal to 0, I 10, and then we got I plus plus. uh, 0.1, 0.1 f. So okay, we will think about it making smoother. For now, add this. This one, yeah, this works fine. It must be kidding. So it's like it's instantly. I guess there are a bit too many resources. So world creator, yeah, let's make resources by 20%. Now, okay, so it's time to work with some UIs. So canvas. Okay, the canvas. Display one. What's our display? HD. Okay, so canvas. Scale with 100. Sorry, I always forget. So in the canvas we need to create new UI. Yeah, let's go with something empty. So stretch. Mm, 0088 to believe stupid 100 position Y100, not minus 100, minus 150. Difference is 50, so 50-50. Need an image. We need an image here. Let it be white. Yeah, let it be white. I don't know what color can we do as well. So in here we add another empty game object, which is gonna be just left side of it, 100 image to be black, position x0, so sorry, 50. So it's like source image food. I actually like this color. And then text mesh pro. Yeah, import them all. So I don't know, like banner maybe. There is a rename that to fruit, and then fruit number. Inside of here we need a fruit. Okay, so no text, so be one on the left side, width 100, yeah, minus 50, local, and in the center one. Yeah, kind of working nice. So, and we need a fruit counter. So it's a fruit. Yeah, you know, actually that's quite a bad idea. It should be inside of some kind of game manager. No, it's not like a level manager, it's a game manager. Okay, so and then rename that as well. What I'm doing is not nice. Usually you want to control it from the start. Otherwise in the big projects there will be errors. So I do believe controlling it in our game manager is quite a nice idea. Where is our game manager? So with that, here we go. Serialize field. Fruits text. No. Private text mesh pro text mesh pro GUI. Yeah. Interestingly, I guess I made mistake somewhere with typing text mesh. Oh yeah, pro UI. Yeah, that's using them pro. Fruit text mesh. Fruit text. I guess that's enough. So and then this private private integer fluid count is equal 0, and then private void update, private void update fluid text is equal fluid count. Yeah, the string. So I do believe if we go to our why it's level manager though, rename. It's our game manager because there's only one game, not levels. Fluids. Yeah, there's no issues like fluid number. Yeah, I know what this issue means now. So I'd like to create collider. Fluid box collider 2D. Is triggered. Should that be on trigger or no? Nah. So and we need our player now. It must have rigid body, dynamic set, asset circle collider, which is nice. So and now whenever player controller, yeah, we don't need this. Object compare type fluid debug collision. Oops. Fluid. What the heck? You know what? On collision state to this, so we got this. We just need to copy this guy to here. Fruit just have a box collider. Okay, yeah. Let's there is something really wrong with players, so whenever it touches, let's do it kinematic. So we got if get, yeah, it's reading my mind, you know, though not entirely. Okay, code точка space. We need to destroy collision. We need to destroy the collision game object. Then we need to oopsie. So we need a game manager thing. Make it first of all to be gettable from other thing. Private awake. Private void awake. Yeah, it's main is equal this, so, and we got here a public. Fluid count game manager main for fluid count plus equal 1. Update fluid text. No, it's automatically updated, I believe. Yeah, it's automatic. It is automatic. I don't care about this mistake anymore. So we got collision to this day. Then, is so the script continues. it's not giving me a message though. Oops. Collision. Don't know what's going on there. Really don't know. Okay, now let's don't need this debugging, and okay, we need to change to work again. Collision, collision, collision detection unity.
Hello everyone. Detect and player for other collision detection, as well as how precise detection methods of collision detection. There's no methods are the opposite. The reason for this distinction is centered around performance. There's no need to run precise calculations on a pair of objects when you can easily tell that they're on opposite sides of the screen. So, that's the job of broad-based collision detection, to work out which objects are close enough to actually warrant a more precise check. There are many methods of doing broad collision detection, and I don't really plan to go from the two that are close to line bound decently is, and it's because it only blind means and bounding boxes reverse the rectangular nature of this. They that they're overlapping. To understand how a computer might work through this, let's break down these two rectangles into their left and right bounds. When there's a left and right bound, switch places. The order is now to the left, just the guides to work this out.
Okay, colliders. Hate it. Yeah, I got monkey. Got monkey.
In this video, we're going to cover how to handle this chat in the zone. It can be, and now let's see, make another obstacle printer. These two over here. So, and hold on, update, called handle. Now, in order to get your engine to make sense, it's there, this will say Okay, now let's apply this to some interest. We can push them around, and there you go. We have a at the end. And finally, over here on the rocks, we can push them around, and there you go. We have a enter, stay, exit, just like that. All right. So here are all of our nice. So that one, when you go in, yep, there you go. We have on trigger enter, a bunch of trigger stays, and a trigger exits at the end. And finally, over here on the rocks, we can push them around, and there you go. We have a enter, stay, exit, just like that. All right. So here are all of our nice collision events. Okay, now let's apply this to some interesting behavior. Okay, here's my player again. Now let's move towards the wall, and yep, stone works as a simple solid object as it's supposed to. Okay. Now over here the rocks, let's push them.
Let's trigger their collision, I don't think we need a box collider anymore. One collisions. Why it cannot stay? Okay, so this piece of shit is also useless for now. Zero references. Box collider, and our player has a circle collider as well. Trigger. Oh no, actually, not technical collider. Oh, what mountain? Don't say it there. So this to be deleted. Oops. Wow. Where can I get it now? Mountain clone. So mountain script remove component, and then we got
And there you go. The rocks are now somehow super heavy, and they cause me some nice damage. So the player's not.
mountain count. player controller, else if. Else if this one is workable. Okay, now why it's not colliding at all? Like, so, but if we go here and then put a kinematic interpolate. Yes. Mm. 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 Thanks.
I don't know why this bug happens, to be honest. Vision stage.
You have four choices when it comes to collision detection. But what do they even mean? Well, let me teach you. Discrete is the default value and by far the cheapest computationally. It works by checking for collisions on each physics step. The downside to this technique is that fast-moving bodies can tunnel through objects between steps, completely missing the collision. One option is to reduce the time between physics calculations. For example, lowering fixed time step from 0.02 to 0.01 will double the calculations in any given time. This will improve discrete hit collisions at the expense of performance and is generally not a good move. Continuous mode ensures collisions, even at insane speeds. It achieves this by sweeping your collider bounce forward linearly to its projected point next frame, like a box cast. If it encounters a collider, it uses that as the impact point, although it's not without its downsides. This mode is quite expensive, and it only collides with static objects. By static, I simply mean objects which don't have a rigid body attached. If you'd like to also target objects with rigid bodies, you're looking for continuous dynamic. This is by far the most expensive collision mode and should only be used when you need accurate collisions between multiple high-speed objects, for example, two opposing projectiles. These two continuous modes fall short when angular velocity comes into play, due to the linear sweeping algorithm not being applicable for rotating objects. This is when you'd opt to use continuous speculative mode. In simple terms, speculative is calculated by drawing a bounding box around the current object and the predicted future position according to its linear and angular motion. Any contact points caught within the box are fed into the calculation to ensure all constraints are satisfied. Speculative also works with both static and dynamic colliders and is quite a bit cheaper than the other continuous alternatives. It sounds great, but it too has its own drawbacks, most notably ghost collisions. Two fast-moving objects may appear to collide without touching. This is due to the predictive nature of the algorithm, which is based on the current motions of the object. Here's a handy cheat sheet. Use discrete if possible. If you notice object tunneling or your object has fast angular motion, give speculative a try. Although there are drawbacks, it's the next cheapest option. If ghost collisions are a problem, or you're still noticing tunneling, swap to continuous. Finally, if you need multiple fast, dynamic objects,
Colliders are a fundamental aspect. Now let's talk about then trigger detection using the on-trigger event. We'll perform a bunch of calculations and spend 24 hours on it just to open a stupid door. We will also look at how to work with compound colliders later in the video. But the main point being parameter of script. If we are only using a simple collider, then a simple on-trigger enter and on-trigger exit event should be enough. But because we're using a compound collider, things are a little bit different. Because compound colliders registers on collision and on trigger events for each individual collider separately, we will need to use a boolean in this case. Similarly, I can implement the on trigger exit event to close the door or perform other actions when the player exits the trigger and what I said earlier in the video, use out, causing all sorts of headaches. Which brings me to what I said earlier in the video, use compound colliders only when you need to. You can see in this script that I compared the tag of the colliding object to player to ensure that it is indeed the player that enters the zone. There are different ways to filter collisions, and let's discuss some effective methods one by one. Using tags, you can utilize the GameObject.compare tag function to filter.
Okay, anyway. Um, if input. Nah, it's not on. Then we need to follow player thing. Controller. Debug. Oh shit. Player controller. New vector 2. LOL. Yeah. Hmm. Lungs. Length. Grass fruit. Grass root fruit. Zero is grass. It's great. It's great. Great. Food animals. Great. Is there a food? plus if is fluid again fluid plus plus is fluid there and then detect key. To find this. Oh shit, it's going to be difficult. No. How am I supposed to do the fruit detect deletion? Fruit position. Let's have that fruits. Yeah, this is it. Fruit position. Fruit position is good. Fruits. Order by fruit position. Order by fruit name. Fruit transform position. Fruit position. This is fruit, yeah, and this is that's game object find fruit plus position x plus position y. find fruit. So I do believe that must be working. That's enough. Fruit position. Anyway, with that I would like to stop to do select system, grass, rock, animal, fruit. Yeah, it's done. My checkpoint here. Done. So add what we need to add some Mountain climbing activated. Lightning, light, lightning system.